Alright guys, welcome to the second video for this week's homework on composite functions. Hopefully you've been super successful with the matching activity and you are able to see where we need to substitute into each function appropriately depending on the order of the functions given. So in this case, if we were looking for a composite function, it would say find f of g of x. You could also say this as find the composition of f and g. You could also, and probably will see it written as follows, parentheses f, open circle g of x. That is another notation that means exactly the same thing. We call this f circle g of x, and it has to follow in order of the variables given. So if we were to do g of f of x, that is an x, we would have g circle f of x. This is just another different form of notation. It doesn't mean anything different. Sometimes they just have it written differently for various reasons. Nothing too important that I want us to focus on right now. Right now, I just want to go into simplifying. So far, we have taken the substitution step, but we've not finished it off with completely simplifying. So that's what we're going to get into now. So this time, everywhere I see an x in my f of x function, because that was the first one given, I'm going to plug in this entire g of x function. And I know I'm going to do that because of this notation right here. It says I'm going to take f, and I'm going to plug in anywhere that I have an x, I'm going to plug in g of x instead. So let's start to write that out. F of, I'll leave some space because that'll be g of x, equals 3, parentheses, plus 4. So we would read this as f of x equals 3x plus 4. That's a plus. However, now we're going to plug in the g of x function because that's what that notation says instead of x. So remember, we're going to leave this as g of x because we're telling people what we're doing with the functions. That is strictly notation, but on the right side, we're actually going to plug in that function. So negative 4x minus 5. So step 1, all we did is plug it in, and we would leave it just like that. But now we're going to take it a step further and go ahead and fully simplify. So if you were to look at this as a Math 1 or even Math 2 student, what the first thing that you should want to do is distribute. And that's exactly what we're going to do. So equals 3 times negative 4 is negative 12x. 3 times negative 5 minus 15. And then this plus 4 just comes down with it. So we have fully distributed. We brought down the plus 4. Now we just need to combine like terms. So f composed of g is equal to negative 12x minus 11. And this is kind of like, if you want to put it in real world context or kind of make it sense in your head, we took one element, the f function, and another element, the g function, and we composed them together. We put them together in a certain order so that we would get something new, which is the negative 12x minus 11. Example 2. So I did say that the order mattered. We're going to look back real quick. So this one, the f function was first, and it was the first one given. That's not always the case, so you do need to pay attention. This one, I'm going to take the g function first, but the g function is the second one given. So do pay attention to that. Let's do green. The g function's first. So everywhere I have an x in the g function, I'm going to plug in my h function. So let's see what that starts to look like. G, I'll leave some space. And that g function looks like x squared plus 2. Now we can come back in and fill that in. So h of x, again, just notation, we're telling people what we're doing, but on the right side, we're actually going to plug it in with x plus 3. Because we're going to take that whole h function here and plug that in. Now, what you should be thinking is x plus 3 quantity squared. You're right, we're going to have to do a box. So we're going to do a nice box over here. Ta-da! We'll just keep it green. It'll be okay. So 2 by 2, x plus 3, x plus 3, x squared, 3x, 3x, and a positive 9. So we'll expand this with blue. So this piece here simplified to x squared plus 6x plus 9, and that's from the box. And then the plus 2 comes down from our original function, okay? And then again, all we need to do is combine like terms all together. I have nothing else to combine with x squared or the 6x, and then 9 plus 2 gives me 11. So G composed with, not F, my bad, h of x is x squared plus 6x plus 11. And that would be your final composition answer. And that box was kind of janky, and that is too. I want it to look nice for you guys. Okay, so some other tips that I have for you guys just to be careful and leery of. Remember, when we plug things into other things, like functions, whether it be variables or numbers, substitution, please always use parentheses. We like to perform safe mathematics. We've had that conversation before. Always use parentheses. If you have negatives, sometimes those get lost if you're not using your parentheses correctly. And that can be a huge game changer when you're going to simplify your function and can make your composite function completely incorrect. So this is the end of our composite functions. All we're doing is substituting it in and then simplifying. That's it. If you guys have any further questions or you're not quite sure on how to work out some of your practice problems for the remaining piece of the homework or the annotated problems on the back, please feel free to come to myself, Miss Mann, Miss Henchman, or Miss Jennings. Hope you guys have a great week and happy composing.